In this video, we will do a review of algebra tiles and the concepts of expanding versus factoring. Let's get familiar with algebra tiles. Operations with polynomials can sometimes involve the use of algebra tiles. Here is an overview. The large green square is positive x squared. The large white square is negative x squared. The horizontal green rectangle is x. Here is x in vertical form. The horizontal white tile is negative x. Here is negative x arranged vertically. The red square is positive 1. The white square is negative 1. We usually refer to these as the x tiles, but these tiles can represent any variable we like. Let's look at how we represent polynomials with algebra tiles. Here's an example. Identify each polynomial represented below. The tiles refer to the variable x. Here we have 3 large squares, green ones, 2 green rectangles, and 4 smaller red squares. This is 3x squared plus 2x plus 4. Here's another example. The tiles here refer to the variable a. We have 2 large white squares, 1 green rectangle, and 1 smaller white square. This is negative 2a squared plus a subtract 1. Let's look at multiplying versus factoring in arithmetic. In arithmetic, we multiply factors to get a product. For example, 4 times 8 equals 32. 4 and 8 are the factors, 32 is the product. We can then do the opposite or inverse of this and factor a number by writing it as a product of factors. For example, 32 can be written as 4 times 8, the factors being the 4 and the 8. The same is true for polynomials. Let's look at some factoring with algebra tiles. Consider the binomial 4b plus 4, so 4 green rectangles and 4 smaller red squares. These tiles can be rearranged into a rectangle multiple ways. Here's one way. We can have a width of 1 because there's one line, and in that line, the length is 4b plus 4, so we can write it as 1 times 4b plus 4. Here's a second way. Here we have 2 lines, or the width is 2, and in each row we have a length of 2b plus 2. Here's a third way. We have 4 rows, so the width is 4, and in each row we have a length of b plus 1. These are 3 different ways to factor the binomial 4b plus 4. Let's look at what it means to fully factor a polynomial. For the expression 4b plus 4, we look deeper into the 3 tile arrangements. Here's our first arrangement. 4b plus 4 equals 1 times 4b plus 4. Our second arrangement, 4b plus 4 is equal to 2 outside of 2b plus 2. And the third equivalent arrangement, 4b plus 4 equals 4 outside of b plus 1. We have 4 rows, and in each row is b plus 1. The first 2 are incompletely factored since 1 and 2 are not the GCF of the terms 4b and 4. The last one is fully factored since 4 is the GCF of the terms 4b and 4. When a polynomial is fully factored, it cannot be factored any further. Let's look at expanding versus factoring in algebra. In algebra, we expand an expression to get a product. In effect, we expand to eliminate brackets. For example, 4 outside of b plus 1 equals 4b plus 4. We've eliminated the brackets. We can then do the inverse of this and factor a polynomial by writing it as a product of factors. For example, 4b plus 4 equals 4 outside of b plus 1, the factors being 4 and b plus 1. In effect, we factor to write the polynomial with brackets. Consider this. 4 outside of b plus 1 equals 4b plus 4. When we go from 4b plus 4 to 4 outside of b plus 1, we are factoring. When we go from 4 outside of b plus 1 to 4b plus 4, we are expanding. We can also do a factor tree for the polynomial 4b plus 4. 4b plus 4, as we know, is 4 outside of b plus 1. Here's our 4 green rectangles and our 4 red squares. So 4b plus 4, using a factor tree, can be factored as 2 times 2b plus 2. Bringing down the 2, the 2b plus 2 can be further factored as another 2 times b plus 1, which gives us 4 outside of b plus 1. This polynomial is now fully factored since 4 is the GCF of the terms 4b and 4. Instead of a factor tree, we could just find the GCF of each term. The two terms in 4b plus 4 are 4b and 4. 4b is 2 times 2 times b, and 4 is 2 times 2 times 1. Therefore, 4b plus 4 equals 2 times 2 times b plus 1, which is the GCF of 2 times 2, which is 4, times the factors b plus 1. Please proceed to the next activity in this lesson, and thank you for viewing.